சபீஷ் யார் ரெக்கார்ட் பண்றா? சபீஷ்
நான் தான் பண்றேன், வருதான்னு பாருங்க. ஸ்கிரீன் தெரியுதான்னு பாருங்க.
இல்ல நீங்க ரெக்கார்ட் பண்ணாதீங்க, வேற யாரும் ரெக்கார்ட் பண்ண சொல்லுங்க. நீங்க ரெக்கார்ட் பண்ணீங்கன்னா கஷ்டம். யாருக்கு ஷேர் பண்ணிருக்கா?
இல்ல நான் டெஸ்க்டாப் ஷேர் பண்ணல, அது பிரபா தான் பண்றாரு.
ஓகே, அப்ப நோ ப்ராப்ளம். ஓகே ஓகே. தென்
நீங்க ஸ்கிரீன் தெரியுதான்னு பாருங்க.
ஸ்கிரீன் தெரியுது.
சூப்பர்.
It's the first vehicle we handed over just half an hour before. My team is
வெளியில போட்டு ஒரு வாட்டி கிளிக் பண்ணுங்க. கேக்குதா?
second vehicle is in progress. Tomorrow we will but that VTC team raising concern like second vehicle that DTL is coming again more like raising concern. That's why we are taking one more shift tomorrow morning. And then Mount Sir also will come tomorrow morning. Then I'll
Shall we start the class?
Yes sir, we can start the class.
Advisors, students join. Can you? Hey, Vignesh, are you able to hear me?
Sir, yes, sir. We are able to
Okay, let us start the class.
Yes, sir. Yes, sir.
Advisors, may able to see whether the group is joined. I want to know.
Yes, sir.
I think there's some feedback from Arunachalam. Noise is coming. Arunachalam, can you switch off your mic? Okay, let me start the class. Others join. Okay, fine. Yes, previous two classes we saw the cruise control, and we also saw how the controller design just started. This was the slide I stopped, if I'm correct. So this is a closed loop control system in which vehicle speed is measured using wheel speed sensor. And they given as a feedback signal. This is called feedback signal. and we have a controller. What is the wheel speed? Measures the vehicle speed in kmph. Number of rotation, all the thing, it measures. That's what is coming. Here, the set point, R is nothing but set point, set speed. Driver is going to set speed. For example, you can say 60 kilometers. Right? So, the set point minus the feedback signal is the error. Already we talked many times. Coming from the wheel speed sensor, that error signal is given as input to the controller. Here, we are using proportional controller. We call P controller, short form, and it has a gain Kp. Transfer function of proportion just Kp, just a multiplication factor. Already we talked about if it is a closed loop transfer system, then we have to find closed loop transfer function for the entire system. Which is shown here at TS. TS equal to output is nothing but this. Y of S is nothing, V of S divided by R of S is set point. I told you if it is done, it is Laplace transform. Okay. Now, that means how will you find a closed loop? Last class I explained, quickly go through. You have to take the forward path gain in the TS equal to forward path gain, note down, divided by 1 plus closed loop gain, closed loop path gain or closed loop gain. In this case, the forward path, you have two blocks. One block is C of S, other one is P of plant. Already we know what is plant transfer function. Already we know the controller transfer function. So that means in numerator, you will get 1 divided by ms plus b multiplied by kp. That's it. According to the forward path gain. Closed loop gain is, I will draw in another color, is nothing but you have to, this is closed loop. Already I told you, here you have one block called H of S. If H of S 1 means, I need not to show the function, this is not needed. Directly can connect by a line. That means the H of S, that is feedback element. Our sensor gain is 1, unity. There is a unity gain. So that means we will never show the box, but nothing wrong in showing also. You can show like this also. Nobody is going to stop. If you don't show the feedback path system, we know that the gain equal to H of S equal to 1. Otherwise, as I told you that you will draw a box, inside that you put H of S equal to what the value is. You can 1, anything greater than 0 you can put. But in this case, unity, there is no need to show. That's why this is not shown. So now, according to what is the closed loop gain? This is a 1 plus, correct? In the closed loop, what and all there? This block is there, this block is there, H of S is there. So 1 plus C of S plus multiplied by P of S multiplied by H of S. Correct? So if I substitute that, it will become, I will write here 1 divided by ms plus b multiplied by kp, denominator 1 plus 1 divided by ms plus b multiplied by kp multiplied by H of S equal to 1. Correct? So now that's what is written here. Correct? The forward path gain, there are two blocks, CS and this one. Denominator 1 plus CV. Here H of S is there. 1 means you generally they don't write. When H of S 1, you need not write. If H of S value is greater than or the 1 or less than 1, but greater than 0, you have to, that also you have to multiply. Correct? H of S can be any value. It need not be a constant. It can be a transfer function itself, like it can have some numerator, just like that, it can have some function itself. It can be anything. But in this case, unity we have shown here. Now, that means if I multiply all this thing, finally I will get this. This is nothing but my T of S. Correct? This is my closed loop transfer function. So this, now I can draw like this. Instead of the whole thing, I can, this is equivalent to this one. It's nothing but Kp divided by ms plus b plus Kp. This is nothing but TFS. So, but the everything is included because this is called block reduction technique. They call as block reduction technique in case of control engineering. See, there is a error and E of, correct? That value is always 1 and controller is there. This is there. For example, you may have H of S also. Drawing all these things become bigger. This can be simplified as single block. That's what this. But it's a closed loop transfer function. That is for the purpose of making, instead of drawing 4 blocks such a big, I can draw as a single block also. Sometimes in some system I may like this. This may be the C of t. This may be R of t. Correct? This is plus minus. Complex system is saying this is not that in the engine itself there are many things, vehicles are many things. Correct? So this is one I said G1 of S, G2, G3, this is G4, this is G5, this is G6, correct? There is one more here, plus minus. Here also minus, this is minus, plus minus, correct? Now you see that so many blocks are there that can be simplified into single block. That is called a block reduction technique. For that you use the formula. There are many formulas are there. Correct? If you know that there's a closed loop function, this is nothing but G4, G5. G4 multiplied by G5 divided by 1 plus G4 multiplied by G5 multiplied by G6. Why? This is the closed loop path. If I take this alone, this is the loop transfer function, correct? The bottom. This is the forward path. So the forward path is written here. The loop gain is 1 plus is written. So this whole thing put together, this becomes single block. Then what I will do? I will show like this. The whole thing is replaced by single block. So now again I can reduce. This can be written as this was G1, this was G2, this one. This is the TS. Transfer, closed loop transfer function reduced, correct? So many blocks. Now I can again write this G1, G2, G3 divided by 1 plus G1, G2, G3 into TS. We are now reduced. So this is the final block. This is called a block reduction technique. So instead of drawing complex this one, I can show both are equal. This and this are equal. Correct? You can do that. But finally, it is both are same only. Functionality, mathematically both are same. Correct? This they will do in control system. Right now we are not understanding. So now we have our plan. What is our plan? This is the cruise control model of the plant with the vehicle model. This is the vehicle model. Already in the previous class we saw. Correct? We got this. Simplified model. Now, that is our plan. Now, and we put a proportional controller. So, with the negative feedback. Proportion to the whole thing with negative feedback. Now, how it works? I want to. So, this is what mathematical model. Closed loop transfer function of with proportion control, you have the system. Now, you can build the actual controller, test it in your vehicle. Correct? Putting the ECU, all those things. Instead of that, you can do simulation. Simulation means this equation you can write as a program. You can write as a program. Correct? Here we have written MATLAB program. Control system development, frequently use MATLAB. Easy. You can write C program, Python program, whichever. The equation you convert to program and feed the data, run the program, you get the graph. This is the output of this program. If you run the program, MATLAB, correct? So this is called as mathematical modeling in simulation. What is the advantage? You don't have vehicle, you don't have sensor, nothing. Everything represented as a mathematical equation. Correct? If you have a computer, you can give different input speed, correct? 60 kilometer, 70 kilometer, 50 kilometer. How the output is. So when I change the speed 0 to 65 kilometer per hour, suddenly I set a step input at t equals 0. How my vehicle, actual vehicle speed, the controller will control. The controller output is going like this. This is the controlled output, vehicle speed. Vehicle speed, this is the step input. Step input at R of t. R of t is nothing but step input. You say that your vehicle is 0 kilometer. Suddenly you ask the vehicle to go to 65 kilometer speed and maintain cruise control. Suddenly you started vehicle, automatic gear vehicle. You put the change this one, correct? But definitely not possible. Actual vehicle will be possible. I told you. First you have to make the vehicle to reach the speed and push the button, correct? Cruise control button. Well, after reaching, then the controller will take care. For make to understand how to design controller, I'm thinking that your vehicle, your controller can set 0 at t equals 0, the x-axis time, correct? T equals 0. You told the vehicle, which one? Cruise controller to maintain 65 kilometers. Step input. They call step input. Now, vehicle has inertia. Why? See the equation. 1000 kg mass is there, right? Some frictional force. All these things will not allow your output to follow the input. Actually, what should happen? Your vehicle, I'm showing green color. Vehicle output also V of t. This green is V of t, vehicle acceleration. The red one was the input, desired input. I made vehicle to start from 0 at t equal to reach 65 kilometer run, same speed. But vehicle, if there's a mass, friction, all those things, it will slowly accelerate. Right? The slope of the curve depends upon your engine power. Right? FD. In the equation, what do you know? FD, that is the forward motion. Correct? Vehicle model. In this, already we know here. FD is the force generated by the vehicle to move forward. All these things are this one. All these things are opposing. Inertial force, aerodynamic drag, and tire friction. All these things opposes. If this is greater, FD is greater than the combined value, then the vehicle moves. Correct? If I want to move faster, correct? So this is called time. See, you see the slowly. So what do you have to do? First, you have to write the program, the MATLAB program. You can go and enter in MATLAB. If you know MATLAB in your computer, you enter and check how it works. Correct? So mass of the vehicle is taken 1000 kg. Frictional constant B in this equation they taken 50. Correct? Set speed they given 10. Correct? Then this is how the mathematical function. Correct? TTF means generate transfer function. There's a command in MATLAB. TF means transfer function. Then if you type in the code and if you run the program, you will get this graph. Correct? So you can see that when here, what is that another thing? KP equal to 100. The gain. KP is called gain of the proportional controller. I said KP value should be greater than 0. It can go up to infinity. Here we set with 100. Then we are performing close to C equal to PID KP. This is the function available in MATLAB to generate proportional integral controller. And only thing is you have to set KP equal to here 100, KI is 0, KD equal to 0. But please see that they called PID function, but they have not defined KI because KI integral control and derivative they are not using. They are using only proportional controller. Other control they have not initialized. So it automatically takes 0. Correct? In case PID function, they are given only KP. You have to give KP, KI, KD, 3 input. If you don't give other 2 inputs, the MATLAB knows that you are giving only first value. Other value will make it 0. Correct? Then you are trying to run the program. T, a variable, is nothing but gender. This is the proportional controller. This is the vehicle model, cruise controller model. And you set the initial value M, B, and input set point. Correct? Then you said make this transfer function. Correct? T, I told you. The transfer function, nothing but feedback, and this one, if you write like this, automatically, then you give a step input, then the output will become like this. Okay. Main thing what I want to say is here vehicle mass taken 1000 kg, damping coefficient 50. reference speed is 10 meter per second, correct? Please know that it is meter per second. Now, kilometer multiplied by 3600. So, here they said this is the speed, kmp, correct? So, 10 meter per second multiplied by 60. The 3600, actually, sorry, it is per second, correct? You multiply by 3600, then you will get so many meter, correct? So, now, if I run, it comes like this. Now, please see that the main thing what you have to do in control system, if I give a step input, correct, this is my input. What do you want in the output? You want like this or like this? Your output should follow input. I want immediately vehicle should reach full speed and maintain. Red is the output, green is the input. Theoretically, we all want, if input is like the output also same shape. But doesn't happen. Why? This is a first order system. Correct? It is a derivative. You can see that E by D is a D. M into S, which was nothing, M into A plus D into V. M into V T of dash plus B into V. Correct? So this is dash is acceleration, this is velocity. And this is a differential equation. Correct? It is nothing but D square by dt square of distance, displacement, correct, multiplied by m. This is nothing but acceleration. This is mass plus b into d by dt of displacement, d of t. Otherwise, since we are talking in terms of velocity, already we saw that this will be d by dt of velocity multiplied by m. This is nothing but acceleration, a, ma, correct, plus b into v, p of t. V is the velocity equal to fd. That's what we saw, correct? So this is a first order differential equation. If your system transfer function, this transfer function is a first order system. In Laplace domain, we are coming, but if a differential equation, it look like this only, correct? If you have first order system, if you give a step input like this, the output will be always exponential. It will never will be note down. It will be never will be like exactly like input. In system control engineering, we have zeroth order system, first order system, second order system, third order, fourth order, like that it goes. Order of this is equal can be infinity, right? If the zeroth order means it is a simple algebraic equation. The model is very simple. For example, I say that f of t equal to kp into et. What is this equation? This equation, what type of is a differential equation, algebraic equation?
Zeroth order differential equation.
It is an algebraic equation, zeroth order. Zeroth order automatically simple. There is no integration differentiation. Correct? Now, if this equation called zeroth order system. If you don't find any derivative integral terms in the equation, we call mathematical model. Mathematical offices f of t equal to kp dt. This is mathematical particular system. Forget what system it is. It has only algebraic terms, no integral term, no derivative terms. Then it is an algebraic equation. Then the system is a zeroth order system. In the zeroth order system, if I say represent my g of this is my g of s, g of system. If I give a step input, what is my output? My output always step output. Exactly will be same. If I give a sinusoidal waveform, my output also sinusoidal. If I give a ramp input, triangle, output also this one. What do you think? What will be the difference? The amplitude will vary. Kp is not an amplification factor. Proportional gain. Correct? The gain alone will be, if gain is unity, correct? If kp equal to 1, what will happen? F of t is input, E of t is output. Sorry, E of t is input, F of t is output. Both will be equal, correct? F of t equal to 1 into E of t. Just 1 minute. Sorry. Okay, some phone call. Okay, no issue. Okay. So now, if it is zero, if it is first order system, if we give a step input, output will be an exponential term like this. It will be like this only. Only thing is, depending upon the slope, correct? The controller gain and system parameter, the output can be like this. Or it can go like this. It can go like this. But never it will be like this. Like input. That is the first order system. First order system output always will be exponential for a step input.
Sir, I have a question over here.
Yeah.
Sir, now only you have drawn the graph, like we have given the step input,
Excuse me.
and now only you drawn a graph, no, sir. Like we have a step input like amplitude and then parallel to that time.
Okay.
So basically, and there is a slave function which is following this exponential graph, right, sir?
Yeah. The dashed line is nothing but your input.
Exactly, sir. So you told that with the varying value, the step
KP.
function may step function may go like this, like it may go above this exponential line, below, but it will never be like the input function, right, sir?
It will not be like input
Now,
function.
for suppose, sir, if a scenario like the vehicle mass is 100,000 kg,
Okay.
and for the given gain, like gain is equal to 4 times,
Hmm.
then it is following this exponential graph like this. Now, if I
Okay.
increase the gain to 100 or 1000, suppose,
Okay.
will that be more sharper than this?
Yeah, it will be like this. I will show you. As the here KP equal to 100. That's what I'll show the next slide, then you'll understand. What you see here. Same thing. KP increase 5000. Still you can see that it is exponential. Then it becomes flat. Right? But it will not be exactly like this, vertical. If you want to vector, what should be the KP value? Infinity.
Right.
Right? But if you make like that, what will happen in the transfer function, this function? If you make something infinity,
It will also become infinity then.
yeah, then it will oscillate. This system, or if you make KP equal to more and more, to reduce this, because I want it has to be, that means instead of going like this, this is KP equal to 100. This is KP equal to, say, KP equal to 1000 or 2 or 500. Correct? Now this is KP equal to 5000. If I make 10,000, the output may be like this. It may go like this. It may look like that. Almost it may go like this. But still it is not there. If I increase, say, for example, 10,000, correct? What will happen? If I give input also, output will oscillate. Some noise input, even small noise, too much gain is there. We say that this is proper gain of system increase too much, 10,000, 20,000 like this. It will become sharper and you are trying to make system to follow the input there. But if any noise comes, immediately output will oscillate. System will become unstable, no doubt.
So is this the reason, sir, when we give the gain to the microphone, sometimes mic, it makes sound.
Exactly. Fantastic. That is exactly same. It picks the feedback signal and become noise. You know that unless it will be making noise, loud noise. Exactly, 10%. That means you are giving too much gain. You are setting the volume, no? That is nothing but changing KP value. What you are doing is like changing gain.
Beyond the point, it will make the sharp noise.
Even small noise comes means it will amplify. Correct? Then system become unstable. System will become unstable. Correct? When KP is very high. Very high means what? 10,000, 20,000, that depends upon system. Why? The overall output depends upon M, B also, apart from KP. See the equation. Correct? For this, the K and B and M are called as what? System parameter. Correct? This system has only two parameters. One is mass of the vehicle, other is the damping, friction, tire friction and aerodynamic friction. Those things we called already we made as a single point B. Correct? So now if I increase gain, it becomes better, but it is okay. Now you don't want this also. I want like this. Output should be like this. Then what you do? Kp equal to 10,000. Correct? So it may happen the output will oscillate. You get a step input, but system will oscillate continuously. Correct? So that means your vehicle speed will go. You see that this is how your cruise control is controlling. Correct? Around the value, correct, 60 mile, it will go to sinusoidal oscillation. Sometimes it can build also like this. Exponential building up. What will happen? That means your car can go 100, 120, again come down, 50, 60, again go down. It happens within very short duration. What will happen? Passenger. Your engine can fail. This can fail. Correct? So much energy you are trying to make oscillation. So proportional cannot be continuously increased to reduce. What is that? That's what I tell you. See, it reaches a steady value like this. Correct? This time is called as settling time. Note down. It is called as settling time. In control system, at t equals 0, it gives the input. The output started increasing. And after some time, for example, after 20 seconds, almost it becomes. So exponential curve. When it will become this one, 1, exponential curve will become 0 to 1 only. Correct? Normalized value. When it will become 1? At t equal to infinity. That means you have to work for infinite amount of time. Not billion year, trillion year. You have to wait infinite amount of time. Then only output will become equal to input. This is my input, step input. The output will reach this one value at t equal to infinite time. But you cannot wait. Generally, we say after 5 time constants, right, 5t, t is called time constant. The output of system will be close to 99.8% of the input. What is the input? This one. This will reach the error. We say steady state error. Note down, these are key words. If you have control system, they will ask all these things. Steady state error of a proportionally controlled system will be close to 0.2%. Error, we are talking E, they call E subscript SS. Steady state error will be equal to 0.2% of this actual value, set point. So how much you reach? 99.8. So 0.2% error, then many times will ignore, correct? Very, very small. 100 kilometers set speed, correct? Your vehicle is 99.8 kilometer, cruise control maintaining their speed. Won't be happy? Do you want to this one? Wait for remaining? Generally, in control system, 5 time constant is more than sufficient for system to reach the steady state with the error of 0.2%. Okay?
Sir, can you repeat the statement, sir, please? I'm sorry. I just got distracted.
Yeah. Generally, in control system, the output will reach the set point. Set point say 100. You set a set speed 100. Vehicle will reach 98.8 kmph after 5 time constants. 5 time constant. Time constant. I will tell you later because we don't have time to talk that. Because that is separate area. That time will explain how to find the time constant individual system. One time constant, how to find out all those things. That all depends upon your system parameters. Your system parameter decide time constant of the system. It can be seconds, millisecond, hours, or minutes, depending upon the M and bigger the system parameter, the system is big, correct? Then system will respond slowly. The time taken, generally one time constant, 1t, they can be equal to, correct, 63.7%. No, I think 67.3%. Very sorry. Correct? Output, the system output reaches 67.3% within what time? It may be 5 seconds. This may be called a one time constant. It may be 6 seconds. That means the output is 63% of the 67.3% of the actual output. Okay, so that we'll see later. But what I want to say is by lower the KP value, proportional control system will not reach the settling time. This is called settling time. Here it is 20%. I say that it has reached 98%. For example, I say, after 20, then I say, but what do you want? You want to wait for 20 seconds to reach steady state value? No. So this is for Kp equal to 50, correct? So you take it. See the next curve. Here, what is Kp? 5,000. What time? This one, settling time. This is Ts. You can see that the output quickly went and reached the almost steady, but there's an error. It has not reached a set point, there's an error, correct? Small error, but it reached a set point, close to set point, 98.8% with 0.2% error. Within what time? 1.8 seconds or 2 seconds, close to 2 seconds, right? Here, it is 20 seconds. Which one do you prefer? You prefer second one, correct? So, if I want a better response, settling time lesser, so the output reaches the set point quickly. If you have only proportional controller, you make the controller gain higher and higher, and see that the TS becomes smaller and smaller. Theoretically, I want TS equal to 0, but the first order system will never happen. Something will be the settling time, correct? That you have to reduce. But if you try to reduce, what you will do? If you still want to reduce, you make this Kp equal to 10,000. Correct. What will happen? The output will start oscillating. It may look like this. It may go very steep, better than this, but it will oscillate. This is not wanted. So that means you cannot set Kp equal to 10,000 to reduce the settling time. Settling time become say 0.5 seconds. That's good then. But system is not oscillating. Even noise is there. So you have to see that your Kp value where oscillation doesn't happen, but Ts is minimal. So how will you do? But you have to wear trial and error. Kp value. Start with say 10, 50, 100, 200, 500. Like that only they tried. The 5,000, it looks better. This experiment, they stopped it.
Sir, that means the more the intensity of the input function,
Okay.
for getting the same settling time, the what I mean to say, Kp value will be required will be lesser compared to a lesser intensity function, right, sir? What I mean to say,
Just 1 minute.
sorry.
Sorry, please go ahead.
Sir, what I willing to say is, suppose the engine is having 20 PS power, okay, sir,
Okay.
and I have set a Kp value of suppose 5,000,
Yeah.
and settling time is about 20 seconds for time being.
Okay.
Now the engine power has reduced to increased to 50 PS, suppose.
Okay.
So for getting the same Kp settling time 20 seconds, I may have lesser value of Kp.
Yeah. The input, see, output is the input multiplied by the gain, Kp.
So is that the reason, sir? The question what I asked the day first to you is,
Okay.
like some vehicles like Honda City, I have friend who is having that. So in that there is a limitation that below 40 kmph you cannot drive the vehicle. So is that the power is so less that even for a less Kp value, the vehicle will oscillate and it will not able to maintain the
Yeah,
speed.
it is not able to maintain, no? The torque, the vehicle when 40, 30 means, correct? So you are running low throttle, no? The torque
Yes.
producer too less. Correct? It may be trying to struggle.
No, I can correlate, sir. Thank you so much.
Okay. Fine. Next thing is what we are seeing. Note down these points because exam you are expected to write these points on that. When you talk about this one, see the understanding one thing, additionally you have to note down important key points. That's why shown here. I'm talking somebody that also you have to write. Okay. So steady state error can be now essentially 0. Correct? It's not 0, essentially 0, very close when Kp equal to 5,000. Compare. Here it was 50. When I increase 5,000, they would have changed. These people, because see, I got it this from MATLAB programming. Somebody wrote in the net was available, or some journal paper from that I took it. You got it? So now they would have tried 1,000, 2,000, 5,000. They say that this one is the best. Correct? So there is essentially 0. Resistance has been reduced. The time, there are two things that are called. TR is called raise time. TS is called settling time. Settling time. Right? So TR is nothing but the output is increasing, correct? From here to here. It reaches, this is 10%, correct? Y-axis. Now, the time taken by output of the system, to reach 90% of the full value. Correct? So this is 90%, correct? You can see here the graph. I am marking. This is 90%. This time, if you see that this time, correct? It may be 0.8 seconds. Correct? 90%. This is 10%. I gave the step input. Output was increasing exponentially. When Kp equals 5,000, it reached 90% of the output. This is 90. Multiply by 10. Correct? 90%. Close to this value. This time is called a TR. This time. Correct? The small time. We want TR should be 0. TS also 0. That is the best system. Which system will have this? Zeroth order system. Zeroth order system, there will not be any time delay. If input is step, output also will be step. Right? First order system, second order system, output will not be like input. There will be a time delay. There will be a time difference between input and output. That is because the first order system, second order system has storage elements. Energy storing elements are there. Energy storing elements are there. In the system, it has energy storing elements. If it has energy storing element, then it will become first order, second order, third order like this. More number of energy storing element, the order of the system will increase. If I add one, then which will be first order system? This will be energy storing element, second order, third order, fourth order, has more number of energy storing elements. Correct? Like a spring, mass, all these things are energy storing elements. Okay? Damper, in a system you can have two things, energy storing elements and energy dissipating elements. Energy dissipating elements. In electrical circuit, what is energy dissipating? Resistor. Resistor is called as energy dissipating element. In mechanical system, damper or friction. In mechanical system, friction or damping elements. Damper we call damper. That is energy dissipating elements. Okay? If system has only energy dissipating elements, in electrical system only resistor, no capacitor, no inductor. In the electrical system, capacitor, inductors are called as energy storing elements. Electrical energy storing elements. Resistor is called energy dissipating. If I have a circuit which has only resistor, no capacitor, no inductor, that will be zeroth order system. If you write the transfer function, it will be algebraic equation, it will be zeroth order system. Similarly, in mechanical system, if you have only friction, frictional elements are damper, and the system has only those kind of elements, that will be zeroth order system. But no, if a mechanical system, if you have, apart from damper, if you have a say spring or a mass and spring elements are called as energy storing elements in mechanical. In electrical, capacitor and inductor are called energy storing elements. Okay. Now, if my system, for example, I show an electrical system, correct? I have a battery connected to resistor. This is my system. Battery has some voltage. Resistor has resistance value. For example, this is 10 ohms. This is equal to 10 volts. I have a switch here, right? At t equal to 0 seconds, I close my switch. Right? What I'm giving? I'm giving a step input voltage to my resistor. My system is nothing but resistor. It is an energy dissipating element. Correct? This is voltage. This is 10 volt. At t equals 0, I close my switch. Before that, there's no voltage across the resistor. Correct? If I represent the graph, this is my input. I apply 10 volts. Right? This is a step input for a zeroth order system. Why? It has only energy dissipating element resistor. Now, what is the output of this? Current. If I apply voltage across resistor, there will be a current flow, I. Correct? I say the I will do a different color. There's a current is flowing from battery and it comes back. I is the output. Current I equal to I is nothing but output. What is input? Voltage. Voltage V equal to input. How much voltage I give? 10 volts. What is the current? Current I equal to V by R. Ohm's law. Correct? In electrical simplest formula, Ohm's law, which we using I equal to V by R. Correct? R equal to V by I. Correct? Or V equal to IR. All are Ohm's law. Correct? What is this is a system. I can write transfer function. What is transfer function of this electrical system? 1 by R. G of S. Transfer function is 1 by R. Correct? Transfer function. So I can represent my electrical system functional block what? G of S equal to 1 by R. What is input? V. What is output? I. What is I equal to? V into G of S. Transfer function. So V into 1 by R. So V by R. Ohm's law. This system is called zeroth order system. If I give a step input, what will be current? Current will be step output. Exactly same shape. Only thing what will happen? The current value will change depending on R value. If I change my R, here R is called system parameter. I have only one element, resistor, that is what I call a system. Yeah, system can have single element alone. Or have 10,000 elements, 5,000 elements connected in different fashion. Correct? So here, now if I vary R, what will happen? 1 by R is called gain. 1 by R is called gain of the electrical system. Correct? If I check R equal to 1 divided by 10 equal to 0.1. G of S equal to 0.1. Transfer function equal to 0.1. Instead of that, if I R equal to 5, how much it will be? 1 by 5. 0.2. Correct? My G of S will be 0.2. So if I then what will happen? Output current equal to voltage multiplied by input multiplied by gain. Correct? 10 multiplied by 0.1, this one. 10 multiplied by 0.2, something else. So if I change the resistance, gain G of S 1 divided by R will change, then output will change. But if I keep the resistance equal to constant 10 ohms, by I vary the input V equal to 0 to 10. What will happen? Output I equal to 0 to 1. If I vary the input, also output will vary. If I vary the system per R itself, I keep V equal to 10. But I vary R equal 1, 2, 3, 4, 5, 10 resistance I'm changing. Still output will change. Correct? Output can change if system parameter changes or input changes. This system is called zeroth order system. Okay? What is a zeroth order mechanical system? Only damper. Damper is the energy dissipating element. Damper is generally shown like this. This is symbol for damper. Correct? Basically, damper is nothing a piston moving inside the cylinder and filled with viscous fluid. Correct? That is oil damper. Correct? Are two sliding surfaces, one metal sitting on another metal. One is constant, other is moving. There's a frictional force. This is all the damper. The frictional damper. They call frictional damper. Correct? In your shock of the motorbike also you have oil damper. They all dissipate energy. Correct? What is the input? For this you apply a force. F is force. Correct? So now this is my piston. Sorry, this is my cylinder. This is my piston, right? This is filled with oil. But small holes are there. In the piston, there are small holes. The piston is connected to like this. This is my piston, solid piston, moving inside the cylinder. This is my cylinder, correct? This is piston. And in the piston, there are small holes. Circular, solid this one. I have small holes. Okay? If I apply a piston, what will happen? The piston will move up and down inside the cylinder. The cylinder is fully enclosed, nothing can leak out, but it is fully filled with oil. Since there are small hole, when piston goes out, the oil will go from here to here and come here, depending on position. Correct? How much oil goes from one side to other side? The flow rate depends upon the RFI size and also the viscosity of the oil. Correct? That is called as a damping constant. That's the equation that is called as a damping constant of damper. That is what B. In the previous equation, we saw DIMP, aerodynamic drag. Correct? Resistive force, we call it a damping. Right? Aerodynamic, tire friction, damper, all these things are energy dissipating elements. Now, this system is called a zeroth order system. If I apply a force, correct, this is position of the piston, Y of T. Current position of the piston is called output. What is input? F of T, force. Correct? How much displacement will happen depends upon the damping constant B. I can write F of T, or is the input, correct? Multiplied by the damping constant B equal to Y of T, where Y of T is the position of the piston. Correct? You see that this simple algebraic equation. Correct? So if we have the damping element or the energy dissipating element, this is system model. This is a mathematical order of the model damper. What is input? You apply force. What is output? Position of the piston. That is output. That depends upon damper constant of damper, which mentioned as B, multiplied by input. Correct? So if I draw with this one, step input, the output also will be step. This is Y of T, this is F of T. F of T is input. B is the damping constant, damper constant. Correct? So these are examples for zeroth order system. Okay? What is the example for first order system, electrical system? I will do the simplest, easy to understand. I have a battery, 10 volt battery, DC voltage. I have a switch, one resistor, one capacitor. This is C, this is R, this is switch, correct? This is input, V. This is input. So, if I close before closing switch, what is the current I? 0. Switch is not closed. At T equal to 0, I close the switch. Step input. Correct? If I give, then current I will flow. Current I will flow. What is I value? You have to find out. You have to write the equation, mathematical model. What is the mathematical model? So I say that V equal to, this is input, V equal to R into I multiplied by, plus, very sorry. Plus 1 by C integral V dt. Correct? So here. Sorry, here it is IDT. We are talking in terms of current. Okay, we are talking, extremely sorry. 1 by C into the integral, this is integral symbol, multiplied by IDT. Correct? So this is the mathematical model of this electrical system. Okay? So if I know R equal 10 ohms, the C capacitor 10 microfarad, 10 into 10 power minus 6. Correct? Then I know V equal 10 volts. I apply. Correct? What I don't know is I. What is I is the output. V is the input. I is the output. Correct? Now it is a integral equation. Correct? You will get a you can convert a differential equation, correct? By doing one time in differentiation, correct? R into d by dt I into 1 by c into I, correct? That's what this one will be there. So that what is the order of the equation? D by dt is first order equation.
First order.
Yeah. Since we added one energy, only when rest was there is a zeroth order. Now I added energy storing device. This is energy dissipating capacity, energy storing element. Automatically, my system becomes first order equation. Correct? What will out if we solve? It will be 1 minus e power minus t by capital T. Correct? This will be the final solution, output. What is the output? The voltage across the capacitor. If see, initially the V of the voltage capacitor will be 0 because of T equal to capacitor, there is no electrical charge. If I close the switch, if I supply step input, the current flowing through the circuit I will be going like this. Correct? So when current is increasing, the voltage DC will start increasing exponentially. Because that's what you're doing. The integration is what? You are going to accumulate the current coming from here like this and get charged. Correct? This will become plus, and the VC will become after t equal to infinite amount time. What will be VC? VC will be same as V input, V input. So both will be 10 volts. How long you are doing? Close the switch, wait for infinite amount of time because I have term E of t in this equation. Correct? Initially 1 minus 1 equal to 0. Correct? If I substitute, correct, for this one, t equals 0, what will happen? E power minus 0. E power minus plus 0, what is the value? Equal to 1. 1 minus 1, 0. That's why output, the voltage, this is nothing but VC. In this circuit, my output is voltage across the capacitor. Input is the step voltage. So the voltage will start increasing like this. Correct? At t equal to infinity, if I substitute to infinity, this will become 0. So VC will be 1. So input equal to 1. Actually, this will be multiplied by 10. Correct? What is 10? That is input voltage. This function multiplied 10. Correct? So into 10, at t equal to infinity, we will get 10 volts. So capacitor voltage and the battery voltage will be equal at the infinite amount time. But after 5 time constant, how much should be? Already told. This is first order equation. Here, if we keep 1 minus e power minus 5 multiplied by 10, how much it is? Calculate. If you have calculated, you can tell. That is 5 time constant, T, the capital T. E power minus 1 time constant. E power minus 2 time constant. E power 3 minus e power minus 5. 1 minus e power minus 5 multiplied by 10. Why this 10? That is input voltage given. This is the solution for the first order differential equation. 1 minus e power minus t by tau. Where tau, t equal to RC, note down. Time, how will you find out time constant of this system? That is nothing but resistance value multiplied by the capacitance value. T equal to time constant, this here, this equation, T equal to 1. Small t is time. Capital T, time constant. Time constant can be calculated. You can see that. See, I am explaining all these things because I know that we take it, but this will be useful. Later when I teach mechatronic course, as usual control system will be useful. I have to teach in control system, but anyhow, since I started, I just wanted to explain a little bit. Okay. How much?
Yes, sir. Answer 9.93.
So, close to almost closer, error will be 0.2%. 10 minus 9.92. 9.98, huh?
9.93.
9.93. So you can find out. If you allow more time, correct? Instead of e power minus 6 time constant, 7 time constant, you will see that the output become close. What we want? Output is same as input. Okay. coming to here, we have to complete. So you cannot go and increase the proportional controller. It will start oscillating. Okay. So generally, that's what unrealistic for the cruise control system cannot change. That's what I told you. Suddenly, can you accelerate? The engine cannot give power. Your controller can generate signal. Will the engine give power? As Rausan was talking, correct? Not possible, Kumar. Correct? The engine won't generate power. So even though you given control, engine power is not, the FD is not there. That is proposed torque develop. It won't. So it will be unrealistic. Right? 0 to 100 meter in less than 0.5 seconds, not possible. Even this is still not possible. You cannot take. Proportional control says that you have to reach a simulation, but actually this it won't happen. Right? So that's one thing. Solution: choose a lower reasonable proportional control gain at a reasonable race time. Correct? So it takes 5 seconds. Correct? Engine had to accelerate. Even if you give fuel, engine will not act. It has a mass, no? Crankshaft mass, flywheel mass, vehicle connected, all these things. So you give a reasonable time so that the engine is able to generate the torque. Controller can generate signal like this, but engine will not have. That's what you have to do. So then you can use integral control elements steady state error. Okay. So like this, we can talk about the KP. Then you can use integral control. Then you can reduce. This is the transfer function of the controller with the integral KP. This is the PI controller. Proportional to integral controller. Correct? Proportional from integral control. What is the transfer function of proportional to integral control? Is this. KP into S plus KI. This is the transfer function of the controller. And what is your system transfer function? 1 divided by MS plus B. This is P of S. Correct? This is my C of S. C of S equal to KP, where proportional gain into S, and K is called integral gain, integral controller gain. Now you can see that now I formed a closed loop control transfer function. This is individually open loop control function of the proportional PI controller. This is the system transfer function. Now I have like this. Right? This is my PI controller, my system, and here I have error amplifier feedback. So now this is my H of S equal to 1. This is my error amplifier. This is E of T. This is R of T. This is my output V of T, Y of T. Right? So now if I ask the closed loop transfer, this is forward gain. Right? This is together KP into I multiplied by, right? It is like this. 1 by MS plus P multiplied by KP into S plus KI in the numerator divided by 1 plus 1 divided by MS plus B multiplied by KP into S plus KI multiplied by 1, because H of S is unity feedback. Correct? That's what we got it here. Final value. Now we are setting gain. KP equals 600. We have additional control, integral control. We put I equal to 1. Correct? If you put 1, what happens? This is what the output comes. You see here. This is for step input. I gave a step input. The output response is like this. This is the for this PI control instead of using proportional controller. Now, but we see that settling time is larger. Correct? Something else second, 7 seconds, you take it 8 seconds. Almost 8 seconds. Correct? Compared to this was taking 20 seconds, just proportional control gain alone with 50, not good. Correct? Then I increased the KP equal to 5,000. The response is better, but system will not, actually engine will not respond. Unrealistic. Correct? Controller can give signal. Engine won't respond. Correct? What do you use? So instead of that, I go for proportional by integral controller. Correct? I gave KP equal to 500, KI equal to 1. Right? So you can see that 8 seconds. 8 seconds it can accelerate. No, 0 to 60 kilometers it can accelerate. Correct? It can 90 kilometers. Correct? A good engine, high performance engine. Correct? So it can reach. but still you want better. What you did, you increase Kp equal to this one, K into 40. You can see that this is 1 and 600. What you do, trial and error you can do. Kp value increase and K also increase. But there are one method is that, don't worry. I'll say that tuning PID controllers. Tuning PID controllers, there are methods, Ziegler method, Nicholas method, open loop method. That I will teach when we talk about control system in mechatronics. Right now we don't have time, otherwise we cannot complete this autonomous vehicle. Our understanding is just saying. If we do that, increase it, you can see that now it has become 6 seconds. Correct? This is 8 seconds. It has reduced a little bit. Better. Correct? So this may be the best value for this vehicle. Cruise controller with a PI controller, you can Kp equal to 800, K equal to 800. This is integral controller gain. Integral controller gain. This is proportional controller gain. To do this, then my vehicle performance, cruise control performance is better. When you give step input, it reaches and maintains. Continues to maintain. If anything changes, it will maintain. Correct? So this is how we design. Last thing is you can use PID controller. This is transfer function for PID controller. Correct? And if you multiply, correct, same thing. Forward path gain, 1 plus loop gain, you will get this. Then you can set Kp, Ka value, you can tune. Using derivative has advantage, but I'm not going to ask you to write about this one, PID controller. I will just tell you simple equation up to this, correct? Proportional control, what is advantage? What I tell, correct? Using those alone and functional block diagram, if you know, that is better. How to control. Okay. Now I'll stop here. I think next few faculty will be waiting. Correct? The portion is what we are talking today for your midsem exam.
Sir, can you go to the previous slide for a second?
Definitely. From the day one, whatever we talk, that's what this one. Somebody asked how the question paper will be. Kumar asked, I think.
Sir, I asked, sir. Yes, sir.
Yeah.
Yes, sir.
1 minute I'll just show. Okay. Shall I close this slide?
Yes.
Because I cannot show both. Just 1 minute. Once the slide is open, I will open that. I'll show you how the question paper will be. Shall I show it? Shall I close this?
Yes, sir.
Yeah. Yes, sir.
1 minute. Are you able to see it? This is end semester exam. Last year, regular students. Generally, a question will be like this. Need not be. I will show you another one also. See, one question will have multiple parts. Define. Explain with functional block diagram. Correct? 1 mark. Talk about to give the autonomous vehicle classification. 2 marks. Correct? Yeah, it will have subdivision. Right? You can see here. Level of automation. Each level explain. Correct? Instead of that, just mention the different level of automation as per SAE. That will be 2 marks. I'm saying what are the explain each level. Level 1, it will have this control, how it works, all this thing explain. 5 marks, correct? 5 marks you cannot write to say level 0, no automation. Level of automation, what under cruise control will be there. That is ABS will be there, level 2, correct? Like that. Level 3 means auto, that mentioning, that will not be 5 marks. Because when I ask this question, this is my regular, so I am teaching the course for regular student, BTECs also. My class takes 80 students. BTEC, MTEC, PhD, all of students are attending this course. And teaching evening for you, daytime for regular students. One student, correct? He wrote this exam, correct? I gave 1.5 marks. He mentioned the names. Level 0, level 5 levels. And with but just mentioning 5 level, everybody knows. Correct? I will give half mark only. 5 level, 0 means no this one. For level 1 means cruise control will be there. Level 2 means already we have mentioned what under will be there. You mention for that, I will give 2 marks. Correct? That is definition or this one. This student wrote only those. I told them to explain each level how each one works briefly. Correct? At least 1.5 2 pages you have to write no, for 5 marks. No, he mentioned this. Sir, I mentioned all this thing. I want 4 marks at least. I said I'll give 0 marks if you ask next time. Read the question. Correct? For example, I said define. So here there are mostly big questions explained in semester exam. Correct? You can see the option. I will show another one. This one. One minute. Just I'm trying to find out. Let me find out. Just 1 minute. I'm trying to see. I'm finding some difficulty in accessing my hard disk, old hard disk, because it will be like this. For example, write definition, correct? Draw the functional block diagram, schematic, correct? Fuel injection system, functional block diagram, and schematic diagram, correct? Explain about it. Mention the advantages, or define, correct? So you have to read the question, how much mark given, what is asked, so you have to write. Correct? Not every question will be 5 marks only. Can it may have 1 mark? It will have question 1, part 1, A. Correct? Define. What is this one? Next line, a simple problem. Correct? Third one, 2 marks. Another thing, 5 marks. Explain with functional block diagram equations. For example, steering system. Correct? We are talking about assisted steering system. Write about it with functional block diagram, mathematical equations, or ABS, functional block equation, all those things. Correct? We talked about many simple equations. Correct? Or find out one problem, 2 marks. We said that this one, engine develops, this is the power, all those things. What is the traction force coming out? Correct? The values are given. You have to remember formula, write the this one, solve the problem, 2 marks. So your midsum exam will be for 30 marks. 3 questions. Each question will have subdivision. 2 mark, 5 mark, 3 mark, 1 question. Q1. Q2 equal to another some 2 mark, 5 mark, something. Q3 can be 2 5 mark question, A, B. Totally 1.5 hour. From the portion what we are talked till now from first day. Okay?
Sir?
Yeah.
Sir, am I audible?
Yeah, yes, please.
Sir, for optimization, we were told that we are allowed to bring some formulas. Similar to that, we are allowed to bring any formulas for this?
Here no formula. What for simple? What is there to bring formulas?
Yeah, I mean, what I meant for some simple equations or anything. whatever.
Simply, you yourself saying simple equation, for that you won't remember. Huh? You
No, sir,
yourself
just
simple
ask.
equation. Yeah, that's a, I am also telling only, simply telling. You are simply asking, I am simply telling.
Okay, sir, understood.
Okay.
Sir,
See
thank you so much. Thank you so much.
Yeah, you come to Mechanical Sciences Block, 2nd floor. My room is MSB 316. My room, my office, same floor. Exam hall is 358. MSB 35. It is called Mechanical Sciences Block. Bring your ID card. Instead of student ID, bring it. Yeah, yes or no, Salam?
Yes, sir. We will bring our ID cards, sir. All are given the information.
Yeah, thank you. Kind of you. See you on Saturday.
Sir, no problems will be asked, sir, for this midsem exam, sir.
Simple problem, I told you, no?
Okay.
Simple problem to 2 mark, 3 mark. I asked some equation, all those things, no? Calculate frictional distance, calculate what is FD, calculate about what is tire friction. Yeah, simple formula, no?
Okay, sir. Okay, sir.
Nothing more than that. I'm not asking you to derivation pages.
Okay, sir. Understood.
Very good. Good luck. Prepare well. Come. See, I will tell you. I want all of you to get S grade. That means in this grade, after 30, everybody should get at least about 25 out of 30. Good luck. My expectation as a teacher. But how you are preparing that time? My wish, then my wish list. If all 24 students get S grade, I will be most happiest person. But for that, both the exam and some both you have to do very well. Do well. It is possible. Right?
Thank you, sir. Thank you so much.
Okay, sir. Thank you.
Thanks a lot, sir. Thank you.
Okay. Bye. I'll close. The other teacher may be waiting, please. Give your attendance as a chat message.